Hi everyone, this is Nirmal Kumar. Today we are going to discuss about motor selection for an electric vehicle. The basic electric vehicle block diagram is shown here. Battery acts as the power source of the vehicle. The electrical energy from the battery is converted to mechanical energy or rotational energy by an electric motor. The battery also powers the accessories like AC, sound system, lights, etc. Transmission system transmit the rotational energy from the shaft of the motor to the wheels. The example of transmission systems are the chain drive, belt drive, etc. When the battery powers the motor rotates the wheel, and this kind of operating mode is known as motoring mode. The same motor can be worked also in generating mode. During this time, the battery gets charged while the motor acts as a generator. We will dedicate a lecture to explain the regenerative action of the motor. Today in this lecture, we will find out which motor is suitable for a particular EV application and how to select that motor. Every motor has a torque speed characteristics. It is also known as mechanical characteristics. The ideal mechanical characteristics of an electric motor for EV application is shown here. While we inspect the graph or the characteristics, we can see that there are two regions, the constant torque region and the constant power region. At low speeds, we can observe a constant torque region. After that, when the velocity slowly increased and when it reaches a critical value or a critical velocity, the region shifts. Above that critical velocity, the region shifts to a constant power region. Electric motor is operated in constant torque region where frequent starting and stopping is required. That is, when we start a vehicle, we need a higher torque. So, uh, constant torque operation is expected during that time. And at high speeds, the motor is operated in a constant power region. So, while we select a electric motor, this is the expected torque speed characteristics. So while we select a motor, the torque speed characteristics must be almost similar to the torque speed characteristics that we have shown here. So which motor to select? There are more than 100 types of electric motors for EV application. We will focus on some of the commonly used motors. So this is a brushless motor. If you know nothing about motors, do not worry. We will give you sufficient materials for you to read and understand in the description section. The brushless DC motor is also known as BLDC motor. Due to its high power density, it is used in most of the EV applications today. So what is meant by high power density? If you are going to take different motors of same power rating, the BLDC motor is expected to have a low size. It does not have brush and commutator while compared to brushed DC motor. So it has a bit more efficiency than brushed DC motor. So mainly there are two types, in-runner type and out-runner type. In in-runner type, we require additional gear systems such as chain drive, belt drive, etc. We have seen these types being used by Ether Energy in their electric scooter. Another type is hub motor or outrunner type. This is the most commonly used configuration or the motor for electric two-wheelers all around the world. Here the rotor of the motor is wheel itself. It only takes less space because additional transmission systems like gears, belts, chains is not required. So that's the reason why it is popularly used in two-wheelers today. The main drawback is the high cost due to permanent magnets. Overloading the motor beyond a certain limit reduces the life of the permanent magnets due to thermal conditions. There is another motor named permanent magnet synchronous motor PMSM, which is almost similar to BLDC motor. It has a good torque speed characteristics and a good efficiency like BLDC motor, and it is also suitable for higher power ratings when compared to BLDC motor. It is usually used in high performance applications like cars, buses, etc. It's used in Toyota Prius, Chevrolet, BMW i3 and Nissan Leaf. I'm sharing some pictures of these vehicles here. Another commonly used motor is DC series wound motor. It has a high starting torque. From the characteristics, we can see that the speed decreases with increase in torque. So it has a poor speed regulation. Since it has a high starting torque, it is suitable for traction application, which means that in applications which required high starting torque, a DC series motor can be used. So these are used in cars, cranes, etc. The next type of motor is DC shunt motor. Its speed torque characteristics is shown in this slide. We can see that when a load is applied to a DC shunt motor, its speed decreases. But the motor is able to self-regulate and quickly compensate for the lost speed. That's why this motor has a good speed regulation. So whenever, even if we apply a load, there will be a sudden dip in the speed of the motor, and after that the motor will self-regulate its speed and go back to its previous speed. However, from the torque speed characteristics, we can see that it does not have a high starting torque as in case of DC motor. So it cannot be used for traction applications. It is basically used for constant speed applications due to its self speed regulation capability. So the next important motor is AC induction motor. The torque speed characteristics of AC induction motor is shown at a constant operating frequency in this slide. From this torque speed characteristics, we can see that it has a poor starting torque. While comparing it with the desired torque speed characteristics of an electric vehicle that we mentioned before, this is far different from the desired characteristics. So we have to somehow make the characteristics of induction motor similar to the desired characteristics needed for an electric vehicle. For that, special control mechanisms are used. Special controllers are used to alter the torque speed characteristics to achieve the desired characteristics required for an electric vehicle. Some control methods are field oriented control and V by F control. If you have some doubts regarding this control, it's okay now because we are not going in depth regarding the control strategies and everything. Anyhow, we will give a reading data in the description box. This controller design and motor controlling is the difficult part in using induction motor, and this is also the major disadvantage. But it has good efficiency, usually greater than 90%, and there is no need of permanent magnet. This is the sole reason why Tesla Model S uses AC induction motor for its operation. And it is a best example to prove the performance capability of this motor. Mahindra Reva also uses a three-phase induction motor. Now Indian Railways has started replacing AC motors with DC. Next motor is switched reluctance motor. Looking into the torque speed cara itself, we can see that it is almost similar to the desired torque speed cara of an ideal electric vehicle. The switch reluctance motor provides a high power density and it doesn't require additional cooling mechanism, and the cooling mechanism design is really easy. However, the complexity in the control mechanism is the major disadvantage. The motor is still in the development stage and it can replace AC induction motors as well as permanent magnet synchronous motors in the near future. Now let's have an efficiency comparison. An efficiency comparison chart is shown. The highest efficiency is for switch reluctance motor and the lowest is for brushed motor. The induction motor and synchronous motor as well as SRM have more than 90% efficiency on load itself. So this efficiency chart can be used for identifying what kind of motor and selection of motor for a particular kind of EV. The cost comparison of different motors is shown in this diagram. Here the voltage and output power rating of the motors are the same. One of the greatest challenge of EV is to provide the electric vehicle in the same price tag of a gasoline vehicle. So cost of the motor is important. We can observe that the brushless DC motor have high cost while induction motor and synchronous motor is more cheaper. Next is the case of the controller. The controller of DC brushed motor is the cheapest while the brushless DC motor controller is more costlier. The induction motor, synchronous motor and switch reluctance motor price is almost the same. So the price of the controller, the motor, the battery, everything depends upon the overall cost of the electric vehicle. So we have to find an optimum value for these things. So guys, today we discussed many things. We started with an electric vehicle block diagram and we moved on to an ideal torque speed characteristics required for an electric vehicle. We discussed various characteristics and features of different kinds of motors like DC series motor, DC shunt motor, permanent magnetic synchronous motor, BLDC motor, AC induction motor, and SRM motor. We discussed different features of this motor just to analyze what are the characteristics and which kind of characteristics can be useful for a particular kind of EV application, so that if your performance is suitable for a particular kind of motor, you should go and select that motor. So some of the important points here is, while designing an electric vehicle, we have to first list down the performance of that electric vehicle. So what do you mean by performance? How much velocity the vehicle can attain? What is the acceleration of that vehicle? And after listing down these performances, we have to look at our budget and select a suitable motor accordingly. We have to find an optimum value that balances the budget and the performance of the vehicle. There are some basic guidelines for designing an EV. For two-wheelers and go-kart, BLDC motors are usually preferred. Usually we use motors which is less than 3 kilowatt. For three-wheelers, BLDC motors are used with or without gear system. While in cases of high performance vehicles like electric cars, electric bus, we use AC induction motor or permanent magnet synchronous motor. The switch reluctance motor is currently under development. This is a good substitute for AC induction motor as well as permanent magnet synchronous motor. So now we have completed our EV motor selection, and I hope that you all are clear with this. And if you are intending to develop your own electric vehicle, you can select an EV motor right now based upon these facts. Thanks for watching. Thanks everyone. If you have any doubt or suggestion, my contact details are given here. Thank you. Have a good day.